Okay, we are going to start with the basics of transformations. So there are three types of transformations that we're going to look at. But the first, let's discuss what a transformation is, not with that color. Okay, transformations. So a transformation is any movement from your parent function. So movement from the parent. So what that means is we know that we've got parent functions that are like y equals x squared, and that, is just like a parabola that looks like this. But we know that we can move these things, and they would move, right? We would have like y equals x minus 2 squared. And that would move it to the left, and it would move, the right, and it would move it to the right by 2 spots. So this is a transformation. All we've done is move our parent function. So we can do this with all types of functions. These movements, transformations, are either horizontal or they're vertical. And all of them will be classified as one or the other. All right, now let's start with horizontal. So horizontal, let's make ourselves a little chart here. A horizontal transformation is going to move things left and right. Left and right. Versus a vertical transformation is going to move things up or down. Okay? So in horizontal, back to horizontal, that's moving us left and right. And that left and right motion occurs on the x-axis. So it usually happens, not usually, it does. It happens on the x. Or, as we're going to start saying, inside is going to be our key word here. Inside f of x. And you'll see what I mean by that in a minute. The exact opposite is true for vertical. Vertical is going to happen on the y, because our y-axis is what goes up and down. And if it's not happening on the inside of f of x, it's going to be happening on what we're going to call the outside, except I can't spell, so there's that. Okay, outside of f of x. All right, so outside. When we're doing a vertical translation also, we're going to do just regular math. So like when we adjust the vertex, like the y in the vertex, if it says +5, it means +5. So that's regular math. And when we're dealing with horizontal, like we were in this example, this is horizontal. See how our parent moved to the left? So that was horizontal motion, and it happened as reverse math. Like this said -2, but it actually moved to +2. So that is opposite math. It does the opposite of what it says. Okay, so there are 3 types of transformations. There are 3 types, and those types are translation, reflection, and stretch. So translation, we've been doing all through grade 11, and we just didn't call it that. So a translation is a shift or a slide. When we move things up, down, left, right, those are translations. A reflection is a flip. So when we flip over the x-axis, we flip over the y-axis, we can flip over anything we want. A stretch, we're going to save for last to look at, but a stretch is when we make something wider or more narrow, right? Which we've done with parabolas over the years. But we're going to start with translations and reflections. And for each of these, they can all be horizontal or vertical. So there's actually 6 types, because we can have a horizontal translation, we can have a vertical translation, we can have a horizontal reflection, a vertical reflection, a horizontal stretch, or a vertical stretch. So they all come in like 2 different styles. Okay, so we are going to talk about translations first. So let's make ourselves a nice chart again. We'll put horizontal over here, and we'll put vertical here. And we're going to start with translations. So we're going to look at the notation on this. So remember, a translation is a shift, right? Or a slide. So it's when you pick something up and you move it. And it could be a parabola, it could be a function, it could just be a shape. But if you're translating something, you're moving it. So a horizontal translation, we're going to give you an example of what this looks like in the notation, would look something like this. It would look like y equals, let's use the example we said before, x plus 2 squared. So this is horizontal because it's going to move it left or right, and I know that's happening because I am inside the bracket and my plus 2 is directly on the x. Now there's new notation for this, and it looks something like this. It looks like f of x plus b. That b stands for the amount we're moving the graph, and in this case we're moving it 2. It's written as f of x because I don't actually care what kind of equation it is. I don't care if it's quadratic, I don't care if it's a radical. All I know is that there's some sort of function and I'm moving it I'm moving it left or right, and I know that because it's directly on the x. Now let me show you what that looks like as vertical. If we were going to do this vertically, it would look a little different. So if I wanted to move my parabola vertically, I would move it like this. I would say y equals x squared plus 2. So this time, do you see how my plus 2 is outside the brackets? Like I don't even have brackets here because my plus 2 is after it. And you know enough about quadratics to know that this would raise it 2. So that's vertical motion. It would move it up and down. Now the new notation for that looks like this. It's f of x plus b. So do you see how my b is outside the brackets? That's indicating to me that it's happening vertically. And that's what it looks like for a translation. Okay, let's talk about a reflection next. So reflections, remember we said those are flips, and they can happen over the x-axis, over the y-axis. They can happen in a lot of different places, and they can be horizontal or vertical as well. So a horizontal reflection is going to be a negative, and it's going to be happening directly on the x. So they're a little difficult to show with quadratics, so we're going to talk about radicals for a second. So if it's happening directly on the x, it would look something like this. The negative would be literally on the x. And this time it's not brackets, but it's a radical, but it's the same thing. It's happening directly to the x. And the new notation looks like this. F of negative x. Again, directly on the x. And this notation is telling you that I don't care what kind of function it is, but there's some function somewhere that is being flipped horizontally. And if it flips horizontally, it's flipping which direction? It's flipping over the y-axis because it's flipping horizontally. All right, a vertical reflection is outside. So I'm going to use absolute value in this example. So again, my negative is going outside my x. So in this case, you would do whatever you need to do inside the bars, and then you've got this negative outside. So that's a vertical reflection. And the notation on that is negative f of x. That's a vertical reflection. So that means that all we're doing here is changing our y values to be negative, right? Maybe we should even write that down. This is your y's multiply by -1, right? Because if they were negative, they'll become positive, and if they were positive, they'll become negative. And actually, what's happening in your horizontal reflections, your horizontal is you're multiplying your x's by -1, right? That's how a reflection works. Okay, and then finally, our last one is going to be our stretch. And we'll just go ahead and complete our chart now, even though we're not really talking about stretch yet, but we'll get there. So a stretch, we've learned with quadratics that a stretch was that a value, right? It was like the number that came before the f of x. So a horizontal stretch is going to look something like this. This time I'm going to use a cubic function. So if we had like y equals 4x cubed, see how that 4 is directly on my x. That's telling me it's horizontal. And the notation for that would be f of a times x. All right? So this means it's horizontal, and it's going to affect your x's. Your vertical stretch is the one that's really the stretch you think of. And it's going to be like this. Y equals 4x cubed. And see how these are different? Because in horizontal, you would take your x value and multiply by 4 and then cube it. But here, you cube, then multiply by 4. And that's what makes it vertical. So that's going to look like this. That's going to be a on the outside times your f of x. Okay, and this is where you multiply your y's by that a value, right? Which is what we used to do when we do quadratics. And then horizontal, I said you do the opposite math. So the opposite math of multiplying is dividing, but what's actually happening is you're multiplying your x's by 1 over a, right? Which is the same as dividing by a. Okay, and remember we said, let's add this, a stretch is your width, right? Narrow or wider. Okay, so these are your 3 types of transformations, and they come in 2 styles, horizontal and vertical.